Welcome to the Override Control workshop. In this workshop, we will gain some experience using override control strategy to enforce an operating constraint on the process. In this exercise, we'll be examining an override strategy in which the set point of the primary control loop is changed over a range in which the constraint is used or not used, and also look at the impact of unmeasured disturbances on the relationship of the constraint and the control parameter. In this exercise, there's a dynamic simulation of a process in which a disturbance can be injected. The manipulated input to the process is also determining the output of the process. One output of the process is of primary interest. It's our control parameter of PID1, and that's our main control loop. It's normally in control, but the output goes through a control selector before reaching the output. And under conditions where a constraint is below a low limit, the low constraint on the process, then the PID associated with that will take over control to ensure that the operating constraint is not violated. To better understand override control and the way the PID controller uses the feedback control signal to avoid wind-up during the condition of it being overridden or unselected, let's look at our workshop, or start our workshop. In this workshop, we have the control set up where the override controller is at set point is at the measured value. In the first part of our exercise, we're going to set the set point of our control parameter also to match our measured value coming in, 50%. And so under this condition, where both the override control and the primary control are at set point, you notice the output of both controllers match each other and are equal to the input to our process at that point. So under this condition, everything is balanced up. We can show what happens though when we start changing our primary control loop to different operating points. So in the first case, we'll change the set point by increasing it to 60. To achieve 60 requires a greater output, and that greater output actually means that the constraint parameter is quite a bit above the low constraint limit, and therefore the output of the primary controller is selected and goes right on out to our process, and we're able to achieve set point. The output of the override control is less than that. It is a value needed to just maintain the low limit. By changing the primary control loop set point to a lower value, though, we start to see where the constraint comes into play. As the output is reduced, at some point the operating constraint hits the low limit, low constraint limits determined by the set point of the override controller, and at that point its output then becomes selected to keep us from violating our operating constraint. Under this condition, the primary controller has been overridden, that is, its output is not selected, and we are unable to achieve set point because to do so would cause us to violate the operating constraint. The relationship between a control and a constraint parameter is very much impacted by other parameters of the process. To illustrate this, we're going to change the disturbance by step. And as we notice, by changing that disturbance input, the constraint parameter now is impacted. It's actually increasing. And as a result, the output of that changes because we're quite a bit above now our constraint limit. As a result, now the main controller here can achieve set point, that its output is selected, and we're able to achieve set point because our constraint parameter is quite a bit above the low constraint limit determined by the constraint controller set point. This is all better visualized by looking at a chart. In our chart, we see at the point where we increased the set point, we were able to achieve set point because the constraint was quite a bit above the constraint low limit. But when we decreased our set point, we were unable to achieve it. That is, the control parameter, the output was selected by the constraint parameter, and the constraint parameter output was selected, and we were unable to achieve set point. When the disturbance occurred, though, the constraint parameter is quite a bit above the limit, and this allowed then our primary controller to do its job and to adjust the output to achieve set point. We hope this exercise has been helpful to you in understanding override control and the way the override control and primary control work in such a strategy. We hope you'll use this exercise to further explore override control and the